Add the complication of Earth's orbit around the Sun, and the seasons are explained. An orbit takes a year. Each day, the angle at which sunlight falls on Earth changes slightly. Over a season, it's a lot. Over 6 months, the change is greatest of all. From this position, it's winter in the northern hemisphere, summer in the south. Short, cool days in the north, long, hot days in the south. 6 months later, when Earth is at the other side of the Sun, it's summer in the northern hemisphere, winter in the south. The oceans influence our climate. They pump currents around the globe, some hot, some cold. But fundamental to climate is the sun. At the equator, where it shines most directly, it causes hot, moist air to rise. This drives 3 great engines of air that circulate between the equator and the poles, air that rises and falls. It's the reason for our winds. If Earth didn't spin, they'd blow north and south. Since it does, they're slewed to the east or to the west. A ring of debris orbits our red-hot proto-Earth after the impact of a planetesimal nearly half our size. This collision is thought to have formed the Moon. It solidifies from crust and mantle splashed up from the planet and from the projectiles that buzz the early solar system. Our infant moon. 4.5 billion years later, it still bears the scars of those impacts, the dark regions, the so-called seas of the moon. They look that way because the interior of the young moon is still liquid, like the contents of an egg. So when the crust is punctured by a space rock, the resulting basin fills with lava welling from beneath. It solidifies into a mare, a sea of dark rock. Such upwelling ceased just over 3 billion years ago as the interior hardened. This is the surface of today. Uneroded by wind or water and bare of vegetation, it is a stark record of impact after impact after impact. At more than 7,900 miles, Earth is nearly 4 times as wide as the Moon and 80 times as massive. Fly 10 times around our equator, and you have the distance to the Moon. The world over, twice a day, tides rise and fall as lunar gravity tugs on the oceans. They bulge at either side of the globe and are pulled ahead of the Moon because of the spin of the Earth. But tidal drag is slowing that spin. Simultaneously, Moon and Earth are pulling apart. Ultimately, our planet will spin only once every 47 days. And Mother Earth is subject to another tug of her satellite. It makes her axis wobble. The cycle lasts nearly 26,000 years. Sunup on Mars, the dusty red planet. Mars is fascinating, for it's the world where we will walk next. It's a little over half the size of Earth, but there's much in common. Mars has an atmosphere, seasons, and a day of 24.5 hours. But the red planet is bitterly cold, at best just above freezing. The Sun is at an average distance of 142 million miles. One solar orbit takes 687 days. Mars, setting behind one of its two tiny moons. They're probably ancient asteroids, petrified rocks captured by an ice-cool planet. Geologically, Mars has a divide. To the south, older cratered terrain. To the north, younger lava plains. For when dust storms kick up on Mars, they can last for weeks and envelop the planet. For an idea of scale, superimpose North America on Mars. The distance from coast to coast is some 2,500 miles. That's the length of the red planet's greatest rift, Mariner Valley. We take a second look, but from closer to the surface. Skimming the craters of the southern hemisphere, we turn west to fly the largest geological fault in the solar system, Mariner Valley. To the highlands west of Mariner and the volcanic dome of Arsia. Another called Pavonis. A third named Ascraeus. But this is the volcanic peak that tops them all, Olympus Mons. Rising over 16 miles, Olympus Mons is 3 times the height of Mount Everest. These cliffs alone are nearly 4 miles high. Olympus Mons is the biggest volcanic peak in the solar system. There's a theory of oceans forming on early Mars because of immense volcanic upheaval. Eruptions melt subsurface ice, quickly flooding the planet. A respectable atmosphere develops of carbon dioxide. Temperatures soar. So why doesn't Mars go green and spark life? One factor could be climatic instability caused by huge variations in the tilt of the planet. But the main reason is volcanic shutdown. No major eruptions to replenish the atmosphere. An atmosphere slowly leaking into space because of weak Martian gravity. Could microbes survive here, bereft of warmth and water? And could we? Is this dusty world a place for human beings? Only time will tell. Jupiter is a giant ball of gas, bigger than all the other planets put together. Jupiter